The next topic is on quality metrics. The students need more care because here we are going to deal with some calculations. Uh, some of the topics need to be explained with the help of diagrams and all. So quality metrics, we can tell that the measurements of a value and performance of your business production, service, and process. So standard of measurement by which efficiency, progress, performance, productivity, quality of a deliverable process, project or product can be assessed. So it can be used to help assess the customer satisfaction level, identify areas of improvements within your company, and track the overall quality of your products or services. Customer quality metrics or measures. So customer metrics refers to measuring factors or tracking them about your customers. These factors are metrics that affects the company's growth and revenue through customers. Customers metrics can be measured with customer satisfaction, loyalty rates, retention rates, and much more. And customer satisfaction key performance index, it's a metrics used by companies to score and track how happy their customers are within the service, product, or experience. The end goal is to determine factors affecting customer satisfaction and to pinpoint the areas of improvement. So generally, the customers use the true performance measures where producers use substitute performance measures. Like example, the true measures of a car door may be easy to close, where the substitute measures of a car door is door closing effect. Sometimes, not sometimes, most of the times the producers educate the customers on their substitute performance measures rather than the true measures of the given product or service. The project management performance metrics enables or helps the project managers to assess the status of ongoing projects in terms of schedule, cost, and profitability. If there exists any potential risk, that they can able to foresee it, and if there is any problems, that to cut down the problems much before they become more severe. Keep a check on the project profitability, assess the productivity of the project team, and assess the quality of work products to be delivered. So for these performance measures or performance metrics measures, we use some of the project scheduling tools like bar charts and activity networks. A project schedule, we can tell it's a dynamic planning, control, and communication tool used by project managers. Project scheduling involves documenting the project tasks, deliverables, resources, and timing. Network diagram is the flow charts that shows the sequential workflow of project tasks, whereas the Gantt chart is a bar chart that shows the project schedule in a graphical representation. Both Gantt chart and PERT chart, PERT stands for Program Evaluation and Review Techniques, are visual tools to helps organize the task when building a project schedule. The obvious difference between PERT and network diagram is that the obvious difference of PERT is it's a network diagram, where Gantt is a bar chart. The examples for the project scheduling is given in the next slide. So here in the table they mentioned about the duration of the task, that is task duration and task dependencies being provided. So here they mentioned about the different activities, its duration and the dependencies. So here, for example, task 1, there is no dependency, task 2, there is no dependency, and task 4, there is no dependency. And task 3 with the dependency T1. That is, task 1, task 2, and task 4 can be started from the beginning because there is no dependencies. But task 3 can start only after task 1, and task 5 can start only after task 2 and task 4. task 6, after task 1 and task 2, etc. like that. So we already mentioned, since the task 1 does not have any dependency, task 2 does not have any dependency, and task 4 does not have any dependency, we can start it from the beginning. So from the table or from the data given here, or from the data provided, make it into a table structure, then convert them into an activity network. See here, as I mentioned already, that we can start task 1, we can start task 2, and we can start task 4 from the beginning. Okay, and then task 3 can start only after task 1. So it will be like this. And M1, M2, M3, that stands for the milestones. See here, it has been given the milestone. M1, the milestone, M1 here as a milestone, M2 here as a milestone. So task 2 and task 4 having a common milestone M2. So the same way that we are making. See here, task M2, task 1, task 2, task 4. This task 1, task 2, and task 4 started from the beginning. Then T3 started after T1 with a milestone M1. Then T5 started after T2 and T4 with a common milestone. See here, both are having common milestone M2, then T5, like that, etc. So from start till the finish, it will go on like this. Okay, like task 6 will be after task 2, then task 9 will be after task 3 and task 6, etc. like that. Once if we created it in the activity network, so here we are mentioning about the duration also, like 8 days, for example, 15 days, for example, then even 10 days, for example, or even either the duration, that is because duration is being given over here, 8 days, 15 days, 8 days, 15 days, 15 days, 10 days, etc. That is being given over here, either by duration by days or by date, that is from which date, from which date to which date. Okay, which date to which date, like that also we can represent. So here, with respect to that, then comes the critical path. So from the data that is been given, we converted that data into a table, and from that table into an activity diagrams. That activity diagram, the task, the duration, the milestone, everything we described. Now it is our duty, it is our responsibility to create the critical paths method. So it's a technique where you identify tasks that are necessary for the project completion and determine the schedule flexibilities. The critical path in project management is the longest path or the longest sequence of activities that must be finished on time in order for the entire project to complete. So how to create a critical path or finding a critical path. So what you want to do is that you need to, simple terms, you want to first from the data create a table, from the table create an activity diagram or project or a project network diagram, and then all the duration need to be represented in each path through the project network, and which is going to be the longest path that will be considered as a critical path. So first build a schedule network diagram, which is a visual sequence of how your task interrelates. Identify all possible paths through the diagram and add up all task durations to calculate the time to complete each path. And the path has the longest total duration is your critical path. See here, one example number 1, start 1, 2, 3. So in this example, we have how many paths are there in the network? We can tell 2 paths. That is, first one is 1, 2, 3, 4, and 6. And then second 1, 2, 3, 5, and 6. Okay. The first path, A equal to 2, B equal to 5, C equal to 2, E equal to 1. So path number 1, that is 2 plus 5 plus 2 plus 1, that is 7 plus 2, 9 plus 1, that is 10. So first path we got 10. And second path, 2 plus 5, 7 plus 7, 14 plus 2, that is, we got 16. So first question, how many paths are there in the network? There is 2 paths. How long is each path? That is, path 1 is 10, path 2 is 16. Which is the critical path? Path 2, that is, which we got as 16, because the longest path. And what is the shortest amount of time needed to complete the project? That is 10. Okay, so another example has been given, like here we are having like A, D, H, J. That is the first one, A, D, H, J. Second one is B, E, H, J. That is the second one. Third one is B, F, J. That is the third one. And fourth one is C, G, I, and J. Okay, so 4 paths are there, and the duration is been given. First path, that is 1 plus 4 plus 6 plus 3, which is equal to 14 days. Second one is 2 plus 5 plus 6 plus 3, that is 16 days. Third one, 2 plus 4 plus 3, that is equal to 9 days. And fourth one is 3 plus 6 plus 2 plus 3, that is 14 days. So which is the critical path? The longest path, that is 16. So the critical path is B, E, H, J. Okay. There are 2 types of network model. One is activity on arc, that is, activity is being represented over here, and activity on node, and activity duration is represented over here. Or sorry, activity is represented over here. Actually, this is an outdated one, so we are using the activities on node. Okay, so the same examples which we described before, we can able to explain it in more details in the coming slides. So here, how the activity on node looks like. So the same, that is, this same node, we are representing it in elaborative way. That is like the activity name, the activity duration, the earliest start time, the latest start time, the earliest finish time, and the latest finish time. Okay, see, when you are making the critical path, okay, when you obtain the critical path, just to remember that the difference between latest start and the earliest start will always become 0, or the difference between latest finished and earliest finish also becomes 0, which is also called as slack. So the slack value will be 0. The slack value will be 0 in the critical paths. So slack, we can able to tell LS minus, that is, latest start time minus earliest start time, or the latest finish time minus earliest finish time. For this, let us have an example for that. Okay, so we are giving the examples in 2 different ways. One is with this normal way, and second one is with this way. Okay, that is activity, everything is represented over there. So here the activity is been given, the description is been given, immediate predecessor is been given, that is dependency is been given, responsibility is given. But unfortunately, in this slide, we didn't mention about the duration. So the duration is given in the next slide. So in this case, when we are describing this information in the network diagram, the description is not necessary, the responsibility is not necessary. What we need the activity, we need the duration, and also we need the dependencies. See here, they mentioned about the activity or the task. They mentioned about the task, they mentioned about the interdependencies, and they mentioned about the activity diagram. See here, in this case, the activity A does not have any dependencies. Task B also does not have any dependencies. So we can start A and B at the starting time. Okay. Then C will be after A, that is been given. Then D will be after B, E will be after B, F will be after A, G will be after C, H will be after D, I will be after A, J will be after E, F, G, sorry, E, G, H, and K after F, I, J, and then end. Okay, it's clear. That is, A and B does not have any dependencies, so A and B can be start immediately. then just to think that which one is having a predecessor value, or which one is been which one can start after the given task. If you remember that we already studied the mapping like first to first, first to last, last to first, and last to last. Okay, so certain activities need to be started only after finishing of the previous activity. So here A and B does not have any dependency. That means there is no activity before A or B. So we can start A and B. But if you want to start I, if you want to start the I, A should be finished. Or if you want to start F, A should be finished. Or if you want to start C, A should be finished, etc. like that. Then the duration, okay, here the duration is not mentioned, but duration is already been here, 12, 9, 10, 10, 24 like that. So what are the paths we can tell? One is A, I, K. Second one is A, F, K. Third one is A, C, G, J, K. Fourth one is B, D, H, J, K. And last one is B, E, J, and K. So these are all the paths. See here, AIK, that is 33 weeks. AFK, that is 28 weeks. ACGJK, 67 weeks. BDHJK, 69 weeks. And BEJK, it is 43 weeks. So which one is the critical path? 69. Okay. So here that is been given, each one having the different represented by different colors, and we already got the critical path, that is nothing but BDHJK, which is of 69 weeks, is the critical path. The longest path is the critical path. Okay, the same can be represented in another way. Okay, before going to that, let us start with the activity time estimates. So the critical paths requires only one-time estimates. That is because each activity with an activity times which are certain, whereas set of in PERT is used when activity times are uncertain. That is, we generally make it as the decision making under risk or under uncertainty. So it requires 3 time estimates for each activity. Just 1 second. So it requires 3 time estimates. So the project, the PERT or project program evaluation and review techniques is used to estimate the project duration through a weighted average of optimistic, pessimistic. So here, optimistic time, realistic time, and pessimistic time. So optimistic time means the best time if everything goes perfectly when doing the activity. Then realistic time means the most likely activity durations, and the pessimistic time is the worst case situation. So we can tell that expected time equal to B plus 4M plus P divided by 6. So PERT is used to estimate the project duration or cost. It is a weighted average estimate techniques. It's best used for planning to ensure accurate scope. It's determined using 3 points like optimistic B, realistic time EM, and pessimistic time P, and the expected the estimation formula or expected to find estimated time, we use optimistic time plus 4 times realistic time plus pessimistic time divided by 6. Okay, with respect to this, let us have a, so here we already have the value 69 as the critical path. So let us start how we are getting the critical path. See here, we are starting A and B from the beginning. So A, the earliest start time is 0, and for B, the earliest start time is 0. And the duration for A is 12, the duration for B is 9. So 0 plus 12, that is equal to 12, and 0 plus 9, that is equal to 9. So this 12 will be the next activity's earliest start time. So 12 will be the next activity's earliest start time. The same way it will go. Okay, so 12 plus 15, that is 27. 12 plus 10, that is 22. 12 plus 10, that is 22. So that will be the next earliest start time. Okay, and here like 9 plus 10, which is equal to 19. Okay, that will be the earliest start time. Then 9 plus 24, that is 33. And here 9 plus 40, which is equal to 59. And 22 plus 35, that is 57. Just see, in this case, we have 27, we have 22, and for here we have 63. Okay, so which should be the earliest start time? It should be, we have three options, that is 27 or 22 or 63. Okay, so while going forward, we will take the highest value. So from 27, 22, and 63, we got 60. We got 63. Like that here we are having two values. Here we are having 57 and 59. Okay, either of these. So we took this 59 because it is the highest value. So while going forward, we will take the highest value, and while coming backward, we will take the lowest value. That means 69 minus, so the latest finish time will be 69. So 69 minus 6, here it will be 63. Okay, so while going backward, we will take the lowest one. So how it is been happening? See the latest finish time, the same way it will be calculated backward, and we will take the lowest value. Okay, and just see if you are considering about each value, that is we already know the critical path. This is the critical path, isn't it? We just check the difference between latest finish and earliest finish, or latest start or earliest start. It will be 0. So here we can tell that B slack value 0, D slack value 0, H slack value 0, J slack value 0, and K slack value 0. So these are all, that is B, D, H, J, K is the critical path. Okay, that's all. Thank you.